What's up, everybody? In this video, we're going to cover USACO's 2021 January contest at the silver level. Problem number 3, spaced out. Farmer John wants to take a picture of his cows grazing in their pasture to hang on his wall. The pasture is represented by an n by n grid of square cells. Picture an n by n chessboard with 2 less than equal to n less than equal to 1,000. So maximum size of 1,000 by 1,000, smallest size is 2 by 2. Generally speaking, it's going to look like a chessboard and it's going to be square. So if I've got 4 rows, I've got to have 4 columns. In the last picture Farmer John took, his cows were 2 clumped together in one region of the pasture. This time around, he wants to make sure his cows are properly spaced out across the pasture. He therefore insists on the following rules. Rule number 1, no 2 cows may be placed in the same cell. Okay, so every cell will either have a cow or not have a cow. Rule number 2, every subgrid of 2 by 2 cells, which is n-1 times n-1 of them total, must contain exactly 2 cows. For example, this placement is valid, while this placement is not, because the 2 by 2 square region that contains the bottom right corner contains only 1 cell. Corner cell only contains 1 cow. So there's only 1 cow in this region. So we have to have 2 cows as a minimum. So let's real quick look at this one, the first one. This one's valid because here I've got 2 cows, and then here I've got 2 cows, and then down here I've got 2 cows, and then here I've got 2 cows. And again, because this is 3 by 3, there's only 2 by 2, 1, 2, 1, 2. There's only 2 by 2 cells to check. Because each of those cells has 2 cows and 2 empty spaces, that's a valid placement. So let's kind of fiddle around with that a little bit. If I were to, I'm going to use X's to mark a cow. So if I have a cow here and here, then looking at the next row, I could have a cow here and here. That would be fine, because then I've got 2 cows here, I've got 2 cows here, I've got 2 cows here. Getting on to the next row, what if I stagger this? If I put a cow here and here, then that looks fine too. That's 2 by 2, 2 by 2, or 2 cows, 2 cows, 2 cows. What happens if I try to put an extra one on this line? If I put maybe this right here. So in this case now, this one's no longer valid. Let's back up. What if I were to do all the way down like this, like that, like that, like that, like that? That looks like that's valid because it looks like every subset is 2 cows. But if I were to shift this one over, let's see that. Looks like that's still valid. 2, 2, 2, didn't change. 2, 2, 2, 2, 2, 2. Okay, so if I were to shift this one to here instead, then now it's no longer valid. If I were to shift that one to here, it would be no longer valid. And if I were to shift it to here, it would be no longer valid. So let's read the rest of the rules and we'll see if we can figure out what the pattern is here. You may have already figured it out. So there are no other restrictions. You may assume that Farmer John has an infinite number of cows available based on previous experience. This assumption certainly seems to be true. Infinite number of cows, right? Okay, Farmer John wants some cells to contain cows more than other cells. In particular, he believes that when a cow is placed in cell IJ, the beauty of the picture is increased by AIJ, where that's between 0 and 1,000 units. Determine the maximum possible total beauty of a valid placement of cows. Okay, so we've got 2 things working for us here. One is we have a lot of different potential cow placements that are going to be considered valid. And then 2 is we've got these numbers here, and we got to figure out of all those cow placements, which one is going to be the best. Now, the number of valid placements is actually quite high. If you look at how this grid works, and if you play with this for a little while, start from just a checkerboard and let's see what it does. If I were to start with just a checkerboard like this is a valid placement. Changes that I can make. I can shift a row to the right. For example, if I were to shift this one, then those X's would move over. And if you think about what's happening, in this cell, I'm going from having a cow here to having a cow here. The number didn't change. In the next cell over, here, I went from having a cow here to having a cow here. So again, the number didn't change. And then if I look here, oops, I missed an X. Because I shifted that row over, I went from having a cow here to having a cow over here. But once again, it doesn't change. So as long as I've got alternating rows or alternating columns in a checkerboard to start with, if I shift a row left or right, it doesn't mess things up. And of course, I could shift that again and we'd be right back where we started. But that rule is going to apply to every row. If I shift this next row, the same thing is going to happen here. Basically, we're going to move from having it on the first one to having it on the second one, or vice versa. Every one of these arrangements is going to be valid. But if I then shift a column after having shifted a row, then everything breaks down. For example, if I shift this one down, then I'm going to have X here and X here. And now I've got too many in this column and not enough, or too many in that cell and not enough in the top cell. If on the other hand, I were to shift it up and let it wrap around, clear that one up. So if that one clears and then it wraps around through the top, I'd have one here and here. And then again, the bottom would be too busy. So your valid placements are going to include only when you are only shifting rows or only shifting columns. Let's real quick read the input format. Input format arrives from terminal standard in. First line contains n. The next n lines, that's n, contain n integers each, right, because it's a square. The jth integer of the ith line from the top is the value of aij. So basically, this is the field and how beautiful each location is if they put a cow in it. The output format, which is printed to standard out in the terminal, is to print one integer giving the maximum possible beauty of the resulting photo, and that is 22. Okay, so we've already kind of fiddled with this a little bit, but if you get a paper and pencil and you play with this, or sometimes actually I like to cut out little pieces of paper and move them around on my desk. It's a little easier than erasing and redrawing things sometimes, to just be able to, or if you have an actual checkerboard and checkers, that might be kind of helpful too. Anything you can use to visualize this. But basically what's going to happen is if we start out with a checkerboard, we've got a valid placement, and any row can rotate in any way that we want it to, which means that we can take this arrangement, or we can take the, I'll do O's, or we can take the O's. And that's going to be the same with these. We can take the X's or the O's. Now, if you think about on this first row, if I were to take first and third, and on the second, I would also take first and third, then the way I'm going to represent that when I'm solving this is I'm going to say on the top row, you took X, and on the bottom row, you took O. If you took X on this row and then X on that row, then that would be the layout that you would have. For each row, because of the fact that you can slide it, rather than sliding the X's and O's over, which I could do that, I guess, if you wanted to write it this way, O, X, but it's the same thing. I'm still comparing evens to odds. So if you think about the X's and O's, not in terms of different values, but in terms of I can choose either one. On any given row, I can choose to take X or I can choose to take O. Then that kind of simplifies the problem. Let me rewrite this here. So let me write this with the grid numbers: 3, 3, 1, 1, 1, 1, 3, 1, 3, 3, 1, 1, 1, 1, 3, 3. So on this top row, if I were to take X's, again, it's going to be X, O, X, O. If I were to take X's, then I would have 3 and 1. So X is worth 4. And if I were to take O, that would be worth 4. So that top row, regardless of whether I take X or O, I'm going to get the same number. Second row, however, is going to make a difference. If I took X, which now is over here, X and X, that's worth 2. And O is worth 4. Now, rather than writing these as X's and O's, because of the fact they're fully interchangeable, let's not actually differentiate them at all, because that's going to further simplify how we're going to draw this. If I don't even bother to differentiate them, then I can just say, did I take the even number or the odd number? So on the top here, even will add up to 4. Odd would add up to 4. So when placing cows on the first row, if I take even, then I'll get a total of 4 points. If I take odd, I'll get a total of 4 points. Let me see if I can clean this up here. Yep. All right, so this was 3, 3, 1, 1, 3, 3, 1, 1. Oops. Okay. Second row, if I take, I'm zero indexing by the way. If I take evens here, then I'm going to take 1 plus 3, which is 4. If I take odds, I'm going to take 1 plus 1, which is 2. Here, if I take evens, I'll get 4. If I take odds, I'll get 4. Here, if I take evens, I'll get 4 as well, and odds, I'll get 4 as well. So it looks like the best thing to do is on the first row to take evens, second row take odds, third row take evens, fourth row take evens. I look at how that breaks down, I've got evens here and here. I've got odds. Why did I take odds? Oh, I shouldn't have taken evens on the first one as well. My bad. Evens. Evens, 1 and 3. Here it doesn't matter. I can take evens or odds. So there we go. And here, evens or odds. There. Okay. So if I were to do this, I have a total of 16. 4, 8, 12, and 16. 16 is the maximum I can get by allowing myself to shift the rows left and right. But we also could shift the columns instead. So let's clean this up, start over. I just have to erase the whole thing here. I don't know if I can, actually, let me see if I can back up through it. Student erasing. There we go. Rest of this I can erase, okay. I don't want to redraw the grid, it's time consuming. Okay, so that's with rotating columns, or rotating rows. If I rotate the rows, then I was able to come up with 16 points. Now we're going to do the same thing, but we're going to rotate the columns instead. So I didn't really leave myself enough room. Let me switch to blank tab here. Okay, so we're going to do even and even. If I were to do even, I would have 3 and 3, which is 6. If I were to do odd, I would have 1 and 1, which is 2. On the second one, if I were to do even, I would have 3 and 3 again, which is 6. If I were to do odd, I would have 1 and 1, which is 2. On this third one here, if I were to do even, I would have 2. If I were to do odd, I would have 6. It's kind of hard to squeeze this in here. And on the last one here, if I were to do even, I would have 2, and odd, I would have 4. And again, for each one of them, I can choose evens or odds. So here I would choose evens, here I would choose odds, here I would choose evens, here I would choose odds. And I have 6, 6, 6, and 4, which is 18 plus 4, which is 22. So 22 is actually the answer. So this is going to be the approach that's going to work. Just to recap why this is the case. With any layout, I'm going to do 4 by 4 again. On any given row, you can either use your rows to choose whether you take even or odds, and you can just test that by playing around with it. I can alternate evens, odds, I can do them in a row, whatever, as long as I'm only changing the row, and then it's alternating. So this is even, odd, even, it's alternating. Or as long as vertically, it's alternating, which would mean cow here, and then I could do like cow here, cow here, cow here, cow here, cow here, cow here. It must be the case that either the rows will have alternating, every row will be alternating, or every column will be alternating. And if you enforce that rule, then it doesn't matter which one you choose on any given row or column. If it's alternating, then you can choose the even numbers or the odd numbers. So essentially what you're doing is for every row, you go through, you add up the total of the even number indexes, you add up the total of the odd number indexes, and just take whichever number is bigger. Add that to your total. Do the same thing with every single row. Once you're done, you will have the largest possible gain that you could get from every individual row. You can add all those together, and that'll give you your total if you alternate your rows. Then after doing that, you save that number. Then go through and do alternating columns. For each column, you add up all the even number values and all the odd number values, all the even number columns and, or I guess rows. As you're going through the column, you add up the even number rows like 0 and 2, and add up the odd numbers separately, the odd number rows separately, 1 and 3. Whichever of those yields a higher sum, when you add those numbers up, you add that to your total, and that's going to give you another total. You compare the two totals, one if you do alternating rows, one if you do alternating columns. Whichever of those numbers is larger is going to be your solution. Alrighty, that's all there is to it. Go ahead and take a good look coding it, and I'll talk to you on the next one.